fine. Thanks for joining me in my shop here. June 4th it is today. Day 2 on this radio. So I've been thinking about this a little bit before I get going on it. And with most radios, I try to get them playing as quickly as possible. And the reason for that is to reduce a very serious risk in doing this kind of work. And the risk is you're going to do a whole bunch to a radio and then discover there's a really bad problem in it. Now what would that be? Blown power transformer, excuse me, blown output transformer, shorted output transformer, something like that. Some, I don't know what else. I don't know what else it could really be, but I'm sure there are a couple more things in there that, like for instance, defective IF transformers and things like this. The way I reduce that risk is by getting the radio to operate as quickly as possible. In fact, many radios I turn them on just as I get them. It doesn't really matter if they're going to work well. I just want to see what they're going to do. I want to see if some sound will come out the speaker. If you touch the antenna, does it make a difference in the speaker? Those few basic things indicate that the radio is essentially all there, and any problems it has are probably quite minor, like capacitors and stuff like that. So this one, having already examined it, found a burned resistor and a whole bunch of really bad looking capacitors, I've decided not to try to start this radio up. But I'm still facing the same risk. Maybe there's something in here that I should know about right now and put this radio away because I'll never fix it. Chances of that are really small. They're really quite small. But much better to find that out early on than to say spend 3 hours changing capacitors in here and then discover that it doesn't work. You know, another situation too is it's good to establish a working level. Let's call it a level. So you turn on the old radio and it does some stuff, makes some sound, hiss, whatever, hum, whatever. You establish a level. Then as you work on it, you can watch this level, this performance level, go up or down. If you don't have it operating at all, you don't have any sense of the performance level of the radio at any point until you've changed a whole pile of parts, and now you turn it on and it doesn't work. Is it because of all those parts? Did you make a mistake in those parts? Is that what you should spend your time on? Or is there some other problem in the radio now that you can go after? All these risks are reduced if you can make the radio operate to some degree right at the start. So, and I can't with this one. So alternative ways to reduce risk of there being a deadly problem in here. I haven't come up with a lot. One is I could test the tubes. Well, one quote deadly problem would be all the tubes are bad. Now, I mean, the chance of that are pretty much nil. But if there's 2 or 3 in here that are bad, I should know about it now. That's a cost. If someone owns this radio, they have only so much money they want to put into it. And that's another thing. I can't be turning around and saying to an owner, well, okay, $700 please for a radio like this. That's yeah, that's my annual income, actually, that amount. So, tube testing, certainly I can perform that right now, and we'll find something out about it. Verifying the speaker operates, there's a couple ways I can do something just to remove that possibility. Speaker's a big problem if it's not working. Power transformer. Well, in some radios you could simply pull the rectifier tube out and kind of operate the radio with just the power transformer running. In other radios you can pull the speaker off. The speaker has a field coil in it. That'll interrupt the power supply, and you can run the radio with just the power supply again, and find out, you know, what it does to some degree anyway. Not with this one. Not with this one. This one has a solid state rectifier. Where did we see that? Somewhere. There it is. You know, I could disconnect this. I'm not sure what my intentions are with replacing this or not. I'm not too intent on replacing it. And boy, the more I look at this capacitor, the more it looks like it's melted. Why don't we take just a closer look at that, because I've become very curious about the look of it. Now that it's out of the cabinet, I have a little better light on it. It's just unbelievable what it looks like. Like, were animals in here chewing on it? What is this one? This one looks like it's got a pile of stuff pouring out the end of it. Is there a fire in here? Did these things catch fire? No, I can't believe it. It melted these wires, or the flame would have propagated right through the radio, I'm pretty sure. It would have had a... These are dark brown colored to begin with. No, I don't think these caught fire, but for a minute there, wow. Really, how does it get like that? That's a real mess. I mean, it's pretty close to this tube. This is the output tube. It's going to run quite hot, and if it was carrying too much current, then it'd be even hotter yet. Is that what did all these guys in? Adjacent heat? Nothing else looks particularly cooked. Okay. Just have another look at the burned up resistor here. Be interesting to test that and see what its value is. Look at the capacitor there. It's really burned. This guy must have got pretty darn hot. He'd be smelly. He'd be smoky and smelly. Okay, tubes. These are all European. No, are they all? They're all European style tubes, but I think I can test them all. I may have to go through a couple of different tube testers. I'm having tube tester problems. Okay, I'm gonna get all that set up and do it. Okay, here we go with the first tube. First tube is an ECH 81. ECH 81. I'm just going to double check the settings here. 6.3 volts. Signal level 4. 15L 00176. 00176. 0035. 0035. 46D. Good. This is a two-part tube. This has a triode in it and a heptode in it. There's a lot of stuff in there. So it's the mixer tube or frequency changer tube. The triode, I'm sure, is to work the oscillator in the radio, and then the heptode is the actual multi-grid mixer. Well, oh yeah, it's glowing. Okay, shorts. You watch the meter for this one. Nothing happening. The test is, we're doing the triode first, 1180. So it should come up about here. It's low. It's quite a bit low. Okay, and that doesn't mean it's no good, it just means it's weak. Now the other test, 45176. 45176. 3200. This should change too to 39. Still stays 15L. Okay, shorts. Watching the meter. This time it's not as high. It should come to 780. 780 is about there. It's just below it. So we have a weak tube here. As I say, it doesn't mean it won't work. Just means it's weak. I guess it could be too weak to work. The oscillator, possibly. The numbers I'm giving that are on my tube tester are the reject point numbers. So really, once it's below that number, they suggest you get rid of it. So this one only has the North American name on it, 6DA6. It doesn't have the European name. My guess is these all had European named tubes, so this is probably a replacement. Okay, 6DA6. Get set up for that. Okay, 6DA6 is also an EF89, and this is the IF amplifier tube. Most radios, the IF amplifier is kind of responsible for the strength of the radio, kind of, not totally. It's where you get the RF, most RF amplification. So checking here, 6.3, 2, 34L, 05176, 05176, 0342, 0342, 34 D. Now I'm trying not to do what pilots do sometimes. You know, pilots use checklists, and I've seen some accident investigations where they just went through the checklist perfunctory. It didn't actually check anything. They just called out the stuff. It didn't actually check anything. It's easy to do that kind of stuff. It's easy to take the easy way. Especially when you're alone here. Even when I have video running. Yeah, video keeps me honest. Here we go. Actually, I keep me honest, to be honest with you. 1170 is what we should get from this guy. 1170 is about where the edge of my finger is. Oh, it's quite low. Oh, jumping around. What's jumping around here? What is doing that? Wow, that went from bad to super good. I better put the other tube in here again. 1170. And it's way up here. It's more than double. Is that a problem? Yeah, that's definitely where it wants to go. Okay, so we've got a super good tube here. Yeah, now I wonder about the other one. It's okay. Eventually, the ultimate tube test is operation of the radio. Okay, next one. This is the tube that was in the shield. EABC80. Look at it, shiny, clean, because it was in the metal tube. Okay, I'll get that set up. Okay, so this tube has 3 tests. Can you see? If I just hold it over this way, it's 3 tubes in one in there. So 3 tests. I'm ready on the first test. Okay, shorts. Nothing. Six AK8 or EABC 80. Easy to get the wrong line here. So we're doing the triode first. It should be 910, so it should be about there, well above. The next 2 tests are diodes, and we'll do them. Zero 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 76 3100 3100 45 A. Diode number 1. There's 3 diodes in here. I think there's 3. Okay. No shorts showing. Doing a diode, we're doing this switch here. Diode number 1. So all diodes have to do is get up above this mark where I'm showing with my finger. Diode. Oh, it's right on the line. Right on the diode OK line. So I think this is a high mileage radio. I think that's what we can conclude here. Now the next one. All different settings again. P3176. P3176. 0K00. 0K00. 38. A. Diodes number 1, number 2, and 3. So we did diode 1. Now it's 2 and 3. I'll throw some switches to do the two different plates. Warm up again. No shorts. Diode switch. Oh, what happened there? We got nothing. How come we got nothing happening? That's not expected. Double check this. P3176. P3176. 0K00. 0K00. That's correct. 38. A. Wiggle the tube, I guess. Yeah, it's just bad tube contact in my. I'm wearing out all my tube testers here. So that's showing okay like that. I think that's valid. And then to read the other, we throw the P1, K1 switches. And I read the other, and it's above the OK also. Okay. We're getting to the output tube now. The output tube is the one I'm guessing let enough current through it, or had enough current flowing through it to burn up the cathode resistor. Okay, and this is a mighty EL84 tube with lots of black soot inside. I guess you could call it soot. Okay, let me get that all set up. EL84. So what? So this tube may very well be worn out, and what worn out means is the cathode is probably physically worn out. So the cathode is made up of a, hey, what are you looking at that for? I'm over here. I'm over here. The cathode's made of a very special material that emits electrons easily at lower temperatures. Now that material wears out as the tube operates, and if you oddly enough, if you operate the heater at a low temperature, there are some low temperatures where the cathode is put at risk, oddly enough. And of course, if you raise the heater temperature and the cathode way up, you can ruin the cathode or wear it out early. Okay, this guy should be heated up. Any shorts in that tube? No. So this guy, 6BQ5 is the North American name. He's supposed to test at 1460. Wow, that's way up here. Well, it's not really. It's right in the middle. It's not way up anywhere. It's in the middle. She's a winner. That's very important. These tubes are a little rare because they wear out under use. So that's interesting in a way. This is the tube I would have thought took a beating, and it's a very interesting looking tube socket in there. I've seen one look quite like that. Fancy looking thing. That's a special heat one. The other sockets are cheap. Here you go. Another tube to test is up in here. I can't get it out of there. I'll try popping this. Oops. Here we are. Not too often we get to pop right into these boxes so easily. Look in there. Do we have any so it looks like all those parts are quite reliable. I'm not going to get in there and monkey around. Good. Okay, and I took that off so I can get this tube out. ECC 85. No surprise. Okay, ECC 85. Get the tube tester set up here for that. So the tube tester I was using can't test an ECC 85 or a 6AQ8. So I got this tester out. This one's the same. It ends at 6AQ7. There is no 6AQ8 for it. I gotta dig out another. These must be a relatively new tubes, of course, and just not in the list. I got a supplementary list somewhere. Well, if one tube tester doesn't do, just try another one. Let's try this one. A TC154. It's apparently another very popular tube tester. I don't use this one with any regularity. What are the chances? Now this is like the similar to the Jackson down below here. This is just an emissions tester, but that's good enough for me. 6AQ5. I guess we look in the book here. What's left of the book? 6. Yikes. Six AQ. 6AQ5. Wait a minute, no, that's not what I'm looking for. What happened here? I got myself confused. Let me just double check. I'm looking for a 6AQ8, not 5. 6AQ. There it is. 6AQ8. The settings are 6D6B3. 6D6. B is scratched in here. B. What happened there? 6AQ. 6AQ8. 6D6B and a 3. What's the 3? 3 is which socket? Yeah, socket. Well, let's give this one a try now. I felt some copper there. No. Don't have a lot of experience with this tube tester. D6B3 off. So it's switched to emissions. There it goes. So on the emission scale, it's coming up in the good the good zone. There's a couple other tests. One is shorts. Probably should have done that right at the start. There's a short light, I believe. And now it's grid leakage. Grid leakage lower scale, it's in the good. There's no grid leakage. Emissions test, good. So on this tube tester, it's good. That's good enough. That's good enough. I mean, this means the tube is operating, and that's really what we want to know. They are all operating. So let's kind of go back in here. And the only other tube is the Magic Eye tube. And the best way to test this is to wait until the radio is operating and then see what it does. It's a little blackened on the screen. And that'll be evidence of high mileage. Very good. What's in store now? I think what's in store is start doing the capacitors and maybe knock out the burned resistor and do the capacitors in the audio area. And that would be basically just this area, just fix up this area, maybe do these two that are on the output transformer. And would it be it's much less risky to operate at that point. There's only, a couple more capacitors left. Looks like I might as well do them all, really. Do them all. So do them all is a risky procedure. It's sometimes referred to as shotgunning. And certainly for me, I managed to find clever ways to make mistakes when I'm doing this stuff. And if you're going to do a dozen capacitors, what are the chances that you don't make any mistakes? Me? Pretty low on a dozen. Yeah, I'm going to think about this just a little bit. Maybe we can spend a little bit of time on the schematic here. Look at that big red warning. This is not the same schematic for the export model Polka 813E. E for export. It may help to repair, but there are differences in the wave bands, mains transformer, and scale. So that's typically what changes when you come over to North America. You have a different voltage level in your outlet, so you need a different transformer or transformer arrangement. The bands, especially a FM band, are a little bit different in frequency, so you need a different wave band for that. And what was the last one? And scale. Well, scale is what I'm talking about. Wave bands. What are the wave bands? What are the wave bands on here? I really haven't looked at that very closely. So let's take a look at the schematic, and then we'll look at the radio itself. Nice layout diagram here. Very helpful stuff. This is the switch wiring help, I guess you could say. There's the solid state rectifier. One side goes right to the chassis. Don't know what that is. Here's the speaker. These must be maybe terminals on the back for more speaker. There's only one. There's only one, but there were two. There's something else in this radio. There was a. There's two drivers in there. Let's see if I can just zoom in a little bit here. There it is, up there. So let's just take a look at how they've done this, because I suspect this is a high voltage speaker. This one's clearly being driven off these windings on the output transformer. 330, I don't know what that means. That's a number, I think. It must be a part number. Yeah, it's a part number. 328. Is there a listing? I didn't think there was a parts listing. So this speaker is being driven. It's a resistor. Isn't that a screen? Driven. Oh, I don't get this. It looks like it's being driven without without a capacitor. It looks like it's being driven from the screen voltage. Wow. 47K. So I don't know. I don't get this. I must be interpreting something wrong here. What's that little dot mean? What is all these? What's this with all the dots? This must be, is this the ground bus running around? No, they're showing it this way. What is that? Just the outline of the chassis? I don't follow. Must be like some kind of chassis outline. Anyway, I don't know why they put a dot there. So 328, is it written on a list? Is there a list? I don't think there is. And that's something. Look right at the schematic and still not be sure about how they're doing it. Well, they're not doing it out of here. So I'm pretty sure this is an electrostatic speaker. Maybe it is, you know what? It's an electrostatic speaker. It is its own capacitor. Sure, you don't need to put a capacitor in. They're using the screen. Huh, okay, that's what they're doing. They're driving it off the screen, oddly. Odd to me, but I'm not the design engineer. These are the tubes I was testing. Not much to see. They've numbered all the pin numbers here. That's helpful. The dual IF, so there's a sort of an AM shortwave IF and then an FM one. I'm guessing which is which. So it's the same IF circuits, the same IF2 really, amplifier tube to amplify both the what I'm guessing is 455 and 10.7. Let's see if we can find a hint on that. It's all in German. I don't even try to say these things. I look at this stuff and oh my god. So here we are. This is it. This is the IF frequencies, and the AM is 460, not 455, and the FM is not 10.7 but 6.75. That's different. Okay, so what I'm really trying to do when I look at the schematic at this point is just familiarize myself with what's on here, look for any hints at this point, helpful things, things I should really know. This is 1, 2 here, not 2. That's the ECC 85. Switch there. Switches. Switches all over the place. Switch, look at that. Switches, switches. Switches on the switches. If there's anything I don't like about these radios, all radios, it's those wafer multi-switch things. Just finished a radio that pretty much burned me out on such a wafer switch. Okay, didn't finish it. It finished me. And a radio that finished me for a change. Yeah, I'm not to lament about that. Look at these numbers here. 3, 7, 10, 6, 5, 3, 8, 9. And then here's the switches right here. These are wired. These might be wires going between 2 points, and that's why they're showing it here as a dot. Don't know. Don't know that part. Look at the power supply for just a minute more. So this is showing a 220 coming in. Of course, that's not what's coming in here. Different selections here. 150, 127, 110. GEWS, so that's a color. Gray, green, something, blue, whatever. This is obviously for doing the heaters and the lights. There's a voltage and a current right there. Some are in brackets, some are not. So it's in two operating states, probably AM and FM. 272, 277. So a little less current, a little more voltage. All kind of makes sense. Yeah, I'm not going to study the schematic in detail. Here's the tone schmozzle. Yikes. And probably more tony stuff going on here. Yeah, good. Okay, let's look back at the radio. Because one thing I didn't really look at was the front dial. Somehow I missed studying up on that. There we go, 4 bands. 1, 2, 3, 4 bands. Reading frequency this way. You can see the meter numbers written up here. What have they done here? So this looks like meter bands. I mean, I don't know, 125 meter band. There's a number scale, a small number scale here. Let me get the close-up camera and take a close-up look at that because it's not coming through. What are they doing on this dial? Start at the top again. This is the AM 550. Is it just a wild coincidence that the frequency 550 equals the wavelength 550 meters? Is that just a wild coincidence? Okay. Come down. Yeah, it says meters, kilocycles. Megacycles, meters. So 7, 6, 5, those are the frequencies. Now, European people, I guess they really like to use the meter way of looking at it, but here in North America, we never use this meter approach. It's always frequency. Okay, so what cities have we got here? Karachi, Guatemala. Imagine, you could tune a radio and listen to all these faraway places like this, like USA. Still listen to the Vatican shortwave. Used to like South Africa. It had a nice tune when they were coming on and off the air. Baghdad. Ecuador. Ecuador, no, that's not a city. Where's Toronto? Toronto never makes it on here, I've noticed. London, Australia, Dakar. Ooh, what's that bottom one? Warzawa. I've never heard of that. Don't know what that is. Must be a place that didn't last long. I don't know. The African country. South Africa's Hungary. Oh, glasses, is it? I think that can just be washed off. That's nothing. And FM goes from 88 to 107, 108. So this is a North American, definitely. But you see, it's backwards. This would drive people a little nutsy. See that arrow under the 90? That's worth noting. Is there another one? There's an arrow under the 98. There's one under the dot. Is there another one? Is there any up here? So there's a little pointer under the 20. Another one down here. Another one under the 8. So what these pointers are marks where someone like me knows to put the pointer when doing the alignment. So these are alignment tick marks. And see that last bar? That's probably, let's see, there's one on the other end? No, one on the other end. So this end, that is probably where you tune the radio all the way Oh. What's going on here? We're not making it. Just a second. My cord was caught. One loop around the pulley there. Well, that's a little surprising. Well, okay, this one doesn't make it. Now, is the capacitor all the way closed? I don't think it is. No, I don't think that's all the way closed. I think it's got a little more to go. Okay, this has got the special, yeah, it's got the special anti-backlash tuning system there. Well, let's try the FM. Yeah, the FM one. Does it make it all the way? Well, that's where it ends. Well, I still bet that's what that line goes all the way up. So I'll bet you that's what that is supposed to be. So discovered a couple more problems, but probably pretty minor stuff. I don't think there's too much else to look at here, eh? Ferrite. Oh, pull knob. Pull knob. Oh! What am I doing here when I pull it? I'm turning on the ferrite antenna? So this is one knob faked like 2 on the volume. This is the volume. Oh, I'm going to guess. You pull the knob to turn on the ferrite antenna. That's worth knowing. That's for sure. Any other little surprises down here? Any little notes I haven't noticed? More notes? All down along here. No. Oh! No, that's just a stock number. And there's the Greatz. I believe that's how you pronounce that. But I don't know. Okay. So another way of reducing risk when you're getting into one of these projects is the thorough initial inspection and the discovery of little things that you should discover soon as opposed to later. But I don't think I found anything that's really horrendous here. I don't see any reason to not continue at this point with some capacitor changes. I really would like to raise the B plus quickly in this radio. Could do a long study, figure out which capacitors are involved in holding back B plus and then change those, and it's too much work. At that point, might as well just do them all. Gonna do them all anyway. Yeah. I think I'll stick with my earlier plan here of doing all these. And then we'll fire up the radio. There's only a few left here and there. And see what we get at that point. And plus do this. I gotta do this. And I'll have to do the bypass capacitor, or should do the bypass capacitor too. It's been cooked. It's probably bad. And then at that point I think we can turn the radio on and see what's up. Hey, thanks for watching. I'm done for today. And I'll be back in here tomorrow. See ya.